minus I2 minus I5 equals 0. So that's the algebraic sums equals 0 for Kirchhoff current law. There is another way to state Kirchhoff current law. You can say that the sum of the input current equal the sum of the output current. So if you just remove all this negative I2, negative I5 to the other side of the equation, so you will have I2 plus I5. So what do you have in the end? You have in the end that I1 plus I3 plus I4, you consider these currents as input to the node, this node, all right? And the output is I2 and I5. You look at 5 and I2, yeah, that's right, it's coming out. So the sum of the in current is equal to the sum of the output current. So that's the second statement. The sum of the currents entering a node is equal to the sum of the currents leaving the node. That's another way. And there's another thing for Kirchhoff current law. Kirchhoff current law is not only applied to nodes, it's also applied to a closed boundary. So if you have circuit like that in front of you, and this broken line define closed boundary, so you can consider this closed boundary as a node, like what it did here. And you look for the current. For example, this current coming out, and this is coming in. Okay, and this one coming in. You look for this. Let me look at blue color. So this closed boundary, you can consider it as a node. Let's call this I1. Let's call this I2. You're looking only for the thing going to the boundary. This one going to the boundary, okay? That's I3. This is coming out, you see, because the current in this call it I4. And this is coming out, that's I5. So don't care about this. It's not correlated to the closed boundary. I'm no closed boundary like a node, and I'm looking for the currents in and out. So you find the current in I2, I3. So you write I2 plus I3 equal the output. The current leaving the closed boundary are I1, I5, I4, I1, and I4 and I5. So you can also look for closed boundary in any circuit. Just to make a circle, you close anything in and out will be the same Kirchhoff current law. So let's just have a simple exercise here. Find I1, I2, and I3. Let's take this one to our notes. So that's a simple one. Try to understand how to solve this one, because you have practice today on Kirchhoff current law and Kirchhoff voltage law. So in general here, we need to find the currents that they are missing. So when you look at this system, or you find you have 5 amp here, you have 2 amp, you have, oh, I3 is unknown. So we don't know I3, you don't know I2, and you don't know I1. So it's required to find I1, I2, I3. Of course, when you solve for Kirchhoff current law, you are looking for nodes. So you just define the nodes here. That's the first step. Second step, yes, it's required to find I1, I2, I3, but you don't have to find them in the same order the question state. What does it mean? It means you have to look for the easy node. What does it mean, easy node? Easy node, when you look at these nodes, you should look for the node that it has only one unknown, not two unknown. Otherwise, you have to write equations, all right? So, for example, let me go for I1 and try, I can do it, or I will leave it for a while. I1, I can get it from using this node, node A, or this node, right? I can use this one or the. Let's look for node A. Do you know everything there? Well, I know that's leaving 1 amp, 6 amp, and amp. Okay, so everything is known except only I1. So I can go ahead and find I1. How you apply Kirchhoff current law in this node A? Well, whatever you like. For myself, I like the one stated that the sum of the currents entering the node equal the sum of the currents leaving the node. So I will say now for node A, the input I1 is entering, and the rest are leaving. So 1 amp leaving plus 6 amp. So I1 is equal 7 amp. That was easy, right? But when you look in the beginning at the circuit or the system here, it just look confusing. No, just follow the steps. Mark the nodes and then look for each node if you have only one unknown. So it was successful try. By node A, we found the current I1. Now I'll go for I2. I2, where is I2? All right, it's not here. It's here, yes. So entering, and you have leaving for M and I3. You see, this node is not really good because you have I2 and I3 unknown. You can write equation and you solve them in the end. What I'm trying to say, yes, it's not wrong. You can write the equation and then I write the equation, you can solve it, but I'm trying to just do it in an easy way. So I'll go for look for B. Node B. Node B, you have everything known except I2. So I will do that because at node B, the current 6 amp entering the node and I2 and I7 and 7 amp leaving the node. So I'll go ahead and I'll apply node B. The in is equal 6 amp and the out is equal I2 plus 7. So I can find I2 equal 6 minus 7, right? That is right. Out is I2 and 7. So it means is equal -1 amp. All right. That's I2. What does it mean -1 amp? It means actually that I2 should be in this direction, not in this direction. That's the state. But since the question give me the direction I2 should be like that, so the answer you don't correct say +1. No, it's -1 according to the notation given in the problem. Now I will move to node C. No, I can't. What do you mean node C? Well, you can do that. That's okay. Yes, node C, the current in that's I3. Okay. So I already did I3, and here we have 2 amp and entering 7 amp. So, all right, the in 7 amp input. So 7 equal to the out. The out is 2 amp and I3. So I3 will be equal 7 minus 2. That's equal 5 amp. So I3 is equal to 5 amp. And you're done. Okay? Easy. Kirchhoff current law. All right? That was a good example. Do you have any question on that? All of you got it? All right. So let's move to other things. So we did that problem already. Now let's move to Kirchhoff voltage law. Kirchhoff voltage law simply states that algebraic sum of the voltage in a closed loop is equal 0. Similar to the Kirchhoff current law. Instead of the sum of the current, the sum of the voltage. But the condition is it's applied only in a closed loop, closed path, mesh. All these names, loop, mesh, or any closed path. And the sum of the voltage is equal 0. All right. So how we'll do that? You have a voltage, V1, and you don't have current yet. So if you assume the current in clockwise direction, and you have the voltage polarity known everywhere, so how do you write it? All right. Let me just use the first method. The sum of the voltage, the algebraic sum. Algebraic sum. What does mean algebraic sum? It means we have some positive voltage, some negative voltage. The sum would be equal to 0. How we do it? There are many ways. Let's look for this way. First, you got to know the sign. of the polarity of all voltage in the circuit. So when you look at it, everything is known. The polarity are given for all elements. You have voltage sources, you have resistance, you have other devices or other elements, and the voltage is known like V5. Polarities are already assigned to each element. So how we start that? Well, you got to have direction. So you can assume clockwise direction or anti-clockwise direction where you want to move. All right. So we are going to travel around the loop in this clockwise direction sense. All right. It doesn't mean that you can do the other way, but it's just I used to do that, so I'm using this method. And then suppose we are going to start from any voltage. Maybe somebody like say I'm going to start from V1, as to V2, V3, whatever you start. For myself, I look for anything that starts from the beginning. This is my beginning. This is my start point that I'm going to start the race of the voltage. So when you look at this V1, some people say, okay, I'm going to look for the first sign. If you have something like that, this is the first time that I'm moving from the sun. So this goes at the first. So that will be always the first polarity. It should be the first. Just mark it. The first sign that you are going to face. All right. So do you understand now? Let me just do it again because we have many things here. So what we are going to do? First of all, you have to make sure that the polarity of each voltage across every element that are given. Second, you got to define the direction that you're going to travel. And let's say we agree, all of us in this class, that we're going to use the clockwise. That the second step, third step, we're going to agree about, we're going to take the first sign of the polarity. What does it mean? It means you have V1 positive and negative. I consider this is the first. Once you choose this is your first, so all the voltage here should be chosen. The first one should be chosen. So how you write that? V1, you write negative V1. V2, that's plus V2. Plus V3. Minus V4. Plus V5. All right, equals 0. So that would be the sum of the voltage, would be equal to 0. That's one way. There are many ways. I'm giving you one way that's used in many textbooks. Okay, so the sum will be equal to 0. So that's what you'll do. Very simple. So the sum of the voltage equal 0. Sometimes we like to write the all positive in one direction, and so that we can write V2 plus V3 plus V5 equal to V1 plus V4. So this is similar to what we did in Kirchhoff current law. So instead of saying the algebraic sum of the voltage around a closed path or loop is equal to 0, we can say that the sum of voltage drops equal the sum of voltage rises. There are something in the circuit that it has a voltage rise and some drop, so both will be equal. Let me just elaborate. How can you do the voltage rise? How can you find out about voltage rise and voltage drop? All right. Well, let me give you some sample here. If the direction of the travel, or in the same, this is a positive and negative, then you ask yourself, okay, if this is positive and negative, and let's say this is the current you assume. So, and this positive voltage is going to produce current in the same direction, we can consider this as voltage rise. So that would be voltage rise. All right. So the current of the coming out in the same direction of the current that we choose. This is our reference that we choose, like this one. All right. So that would be rise, because it's helping, supporting. And if you look for the power, this one generating positive power, this source. So it means voltage rise. For voltage drop, I'd like to take this example. if you have a resistor and the resistor, the current going in this direction, so it will be voltage drop because this resistor will be consuming energy, right? Consuming power. So, and you observe that the current of the reference here is entering the positive. Here, the current coming out of the positive. So when coming out of the positive, generating power, it will make rise voltage. But when the current entering the positive will be consuming energy, so it will make voltage drop. So that's how can you find the voltage rise and voltage drop, and both are equal. Okay. Well, I know when I was student, when this thing explained, okay, I understand. So when the current coming out of the positive, it means generating power, that will be positive voltage rise. That makes sense. And the same thing for the resistor. If you have a resistor and the current entering here, it means current entering the positive, it will consume energy. The resistor will consume energy in this case, so it will be voltage, causing voltage drop. And the same thing, if you have, let's say now, you have a voltage source and the current entering the positive will be the same voltage drop. So that's like, I mean, if the current coming out of the positive is generating power, it's positive, it's voltage rise. But if the current entering the positive, it means it's consuming energy, that will be voltage drop. Easy. But when I was a student, as I told you, I need an example to make sure of. All right. Let's just, I have an excellent example. You see, like you have 4 loops in this one. Just let's take it and understand it. In this example, make you understand exactly how you apply Kirchhoff voltage law. I like this kind of example. Okay. It's required to find the voltage V1, V2, V3, V4. And let us just mark them. Right, where V1, that's V1, V2, V3, V4. I marked. You remember when we did before Kirchhoff current law? I marked the nodes. And of course, look at the current. So, but I want to mark here the voltage because I want to know which one should I start. Do you need V1? Do you need V2, V3, V4? So you got to choose the closed path that has only one unknown voltage to make it easy. So if you look for V1, you have this loop and this loop. So which loop you choose? If I choose this loop, you have, okay, let me tell you about something else. Let me just to make it easy. So when I will call this, I give a letter just to explain. You don't have to do it when you solve the exercise, except if you want to practice this to get familiar with the Kirchhoff voltage law. But let me just give a letter here. E, F, G, H, I. Okay. I will make it K, so you'll not think it's current. So I give names. So when I call a loop, I will mention the loop. So to find V1, you have this loop A, B, K, H. Can I do A? So this is a closed loop. But the problem in this loop, I have 2 unknowns. So it will not be easy. Let me look for the other loop that has V1. I look for the loop B, C, D, K, B. I have V1, V2, unknown. It doesn't work. So I will not be able to find V1 now. I will just delay it for a while. Wait. Let's look for V2. V2, I have the same problem. So I will wait for V2. I can't do V2 now because the loop has 2 unknown. All right. Let's look for V3. V3, I have this loop and this loop will be 2 unknown. So I don't have except only V4. V4 in the loop K, D, E, F. K. That's right. It has only 1 unknown. You see how I choose? I choose to start with V4 because all loops for other voltages, I will not be able to find it because there are 2 unknowns in each loop I choose. So the best thing to do, I'm going to start solving for the voltage V4 using the loop K, D, E, Fk. I'm going to use this loop. You see? Oh, okay. That was a good idea to call each node, with a letter, so you will understand which loop. Now, if you follow this letter KD, it means I'm looking for this one. The sum of the voltage could be equal 0. So let me just the sum of the voltage, the law Kirchhoff says sum of the voltage is equal 0, closed loop. So you got to assign a direction. I do that. I'll start with any voltage. Here, this one. All right. So V4, we agree that we're going to use the first polarity. So this is the first polarity, first polarity, first polarity, nothing else left. All right, that's easy. Now, excuse me, V4 will be minus V4, minus V4. And then I go move with the arrow. I face 2 voltage is positive, plus 2 voltage. And then I continue with the same direction. I face positive 5 voltage, and then I go only wire equals 0. So I have negative V4 plus 7 equals 0. So V4 is equal 7. Ah, that's easy. Okay. All right. Let's find another voltage. All right. But once you find some voltage, you got to put the value of it. V4 we found equal 7. So you write just equal 7. All right. So I can now move to this. Oh my gosh, I lost the old letter. Oh, that's okay. I don't try it again. Oh, what? That's I never. Okay, let me just take picture of a picture. That's okay. I want to keep the same letter, so when you review, you will not be confused. Okay, that's good. Now, just we need some adjusting. That's equal 7 voltage. So I will go to the loop. Which one? I go to the loop H, K, F, G, H. Can you see this loop? All right. Let me just point at it. I will look for this loop. All right. Why? Because I know everything except V3, so I can find V3. So we'll do the same thing. Let's just assign the same direction, and I will start with this voltage to the left, and I'll choose the first polarity here. All right. Just let's write the equation. You will have positive 4 voltage, and then you move, you will find positive V3, and you move V4 is already known, that's positive 7 is equal to 0. From this equation, you can find V3 equal to minus 4 minus 7 minus 11 voltage. All right, and you put here equal minus 11 voltage. Easy, right? I found V4, V3. Now we can find V1. I will go to the loop, which is A, B, K, H, A. I will do the same thing, and I will choose the first polarity here. Right? So let me, not to confuse you. Every time when you take something, just update it. That's the first, the first. All right. Even if you want to make it more clear for you, you can write that V3 is equal negative 11. So you can write negative 11 voltage and put the sign negative positive here. And they go for the lead color and they mark here. So now I'm going to write the Kirchhoff voltage law. I start with -3 voltage. And then I continue, I have positive V1. And then I have negative V3, and V3 by itself is equal -11. Don't forget both signs. So I have -3 plus V1 plus 11 equals 0. So you have 9 plus V1 is equal 0. So V1 is equal to -9 voltage. Okay, we got V1. All right, that was a good practice for this one. Well, what's left? I got V1, V3, V2 left. But you got to, I have V2, I want to find it. So first of all, oh, you can't get rid of this sign. Well, so what we're supposed to do, let's just, I will sketch this loop separately, not to confuse you. And when you review, when I make a copy of it, you will understand it. That's loop B, let me write it here, B, C. Why I'm going to do that? Just let me copy this part and redraw it again. This part. Only this part. Actually, it's good, you know, you'll be focusing on in this loop. And we'll put and I'll sketch next to it. You have a circuit like that. You have an element. The beautiful thing about this
-8.
Pardon me?
I think V1 might be -8.
Oh, yes.
Because
I just, yeah.
3 plus 0 and then -11.
Are you talking about V1? The V1 is right, or I did the error in V1, or it's correct?
V1 is -8.
Oh, I'm sorry.
Because
Okay.
you do
Thank you.
3 minus 11.
Oh, okay. Oh, I see it. Yes, I saw 2. That's right. Thank you for telling me that, because it will affect the rest. Yeah. You have B, C, D, K. I'm sketching this loop again. So you have positive, negative V1, which we found now -8 voltage. And I don't change the sign positive and negative, see, because it was given there, but I don't change any sign. I'm using the same sign that was given in the problem. Negative positive V2 2 voltage, I'm sorry. So that's the loop. And what I'm going to do, I'm going to do the direction. So now I'm going to do the same thing. I will say I'm going to start from the first polarity. And I will write the Kirchhoff voltage law. So I have the loop B, C, D, K, B. Okay, that's a closed loop. I start with, I have negative, and then you have you have to be careful about the sign. This is the negative. Let me just tell you what is negative. This is the negative. And -8, this is the value itself. Okay, you got to pay attention to this one. So, and then I move clockwise direction. If it's negative, another negative, V2. I move, I have another negative, 2 equals 0. So you got +8, negative V2, -2 equals 0. You got 6 minus V2 equals 0. So V2 is equal 6 voltage. And you are done with the Kirchhoff voltage law. It was a good problem because you got like 4 closed loops, and how you solve this one. You will not find something more difficult this exam. I hope that you understand Kirchhoff voltage law and Kirchhoff current law. These 2 laws are really important for solving electric circuits.
And Professor,
yes,
the PowerPoint will be on the
I couldn't see.
Canvas.
Oh, the attendance, I did the attendance. Okay, I did the attendance. Somebody else come, just let me see, because I did the attendance once I entered. Let me go and see if anybody came right now. Oh, there are some people came.
The notes will be on Canvas.
Let me update it. Yeah, but try guys to be early on time because it like the first 5 minutes you'll be okay. And I update now.
The Kirchhoff's laws PowerPoint. It will be on Canvas.
I'm taking the attendance right now.
Oh, I know.
I think I updated. Yes, go ahead. What you're asking?
The PowerPoint that we did today.
Yes,
It's going to be on Canvas.
Oh, sure. Yes.
Okay,
Yes,
thank you.
it'll be on Canvas, of course. Yeah. But just of course, after I write the solution, then I will. What I do. I have already like Word file has the problems with the solution. Once I'm done, I cut all the solution that I did. We did together, and then I would paste it in the file and then convert to PDF and then put it there. So it will take like 15 minutes maximum, and then it'll be on the accounts. Yeah. Okay. So do you guys understand Kirchhoff current law and Kirchhoff voltage law? All right.
Yes.
Now let's go ahead and move to if you have the problem. If you look at the problem here we solved, the current direction and values were given. And in the applying Kirchhoff voltage law, we have circuit with elements and the voltage signs are already assigned. But in actual problem, when you have a circuit problem, these things are not given. We assign the voltage polarities to each element. So I'd like to move one step ahead, but I want to make sure you understand first Kirchhoff current law, Kirchhoff voltage law, when the polarity signs are given for the voltage across each element. Now we'll have a real problem. You have a circuit, and by the way, the circuit is could be practical. We have all this resistance. As in a project, maybe the resistance represents motor, maybe represent light bulb, maybe represent anything. Okay, all this resistance, and you have supply 45 voltage. The question is, do you want to find V2 and V4? V2 and V4. Let's go ahead and see how can apply Kirchhoff voltage law and Kirchhoff current law to solve problem like that. So when you look at that, of course, in the question, they have to give you the polarity for V2 and V4 because he asked to find V2 and V4. If the question didn't, in the question, they didn't give you the polarity for V2 and V4, and when you solve the problem, you maybe one student will make the positive here, the negative here, somebody else will make positive and negative here. So they want to have unified answers. Okay, I want voltage across 4 kilo ohm measuring this side, the positive side, with this negative side. All right, and the same thing for V4. So these are given, but when you look for the rest of the circuit, you don't know the sign in 6 kilo ohm, 3 kilo ohm. You don't know the sign here. So how can you apply Kirchhoff current law or Kirchhoff voltage law? First of all, you don't know the current. So how you assign? See, so that's the problem now that we are facing. So what we're supposed to do?
I just have a question.
Yes, go ahead.
Can you just look at the voltage source? Because the longer bar is on near A. So that means
well, yeah,
that's
the positive, that's the negative. Yeah, that's known. Yeah. So the voltage source, okay, we don't have problem because this is here the long side, this is your side. You are right. So the positive is given. Yeah. But for the other one, like 6 kilo ohm, I'm sorry, this is one given, and 3 kilo ohm, we don't know. Add to that, we don't. Pardon me?
Well, since there's already actually, never mind.
No, I couldn't hear you well.
Never mind.
Okay. So what is the second step? The second step, I should assign currents in the circuit. All right. So, and you can assign current anywhere you like. Anywhere you like. So, for example, if I say that there is current coming out of the source in this direction, that will be I. And then it comes to the node B, this current will split, one in this direction and one other direction. So I call this one I1, and I call this current I2. So it means, it makes sense, right? So I have now this node B, I have current in, which is called I, then is split into two currents. I call this one I1 and I call this I2. This is the node that I have. And then after that, you will see I2 will continue in this direction and I1 continue this direction. So I2 is going here, going there, and I1 going in this direction. So I can apply Kirchhoff current law in this node, and I can say I is equal I1 plus I2. So this is the one equation I know. You just keep it there, mark equation 1. Once you do that, and you define the direction of the current, second step is to define the polarity across each resistor. Why? Because the current direction now is known. And we know that if you have a resistor R and the current going in this direction, so it will make this positive, it make this negative. That's in the resistor. So if you have any resistance and you know the direction of the current in the resistance always entering the positive, leaving the negative. Inside the resistance is moving from positive to negative, all right? So according to that, I'm going to assign the polarity for 6 kilo ohm. The current is flowing in this direction. It will make positive, negative. I don't have other resistance. I have 3 kilo ohm. 3 kilo ohm, the current is going upwards, so it will be make this positive, negative, voltage drop. The rest of the polarity are given. Excellent. So what's next? Okay. Now I finished with Kirchhoff current law. I finished with assigning polarity to each, not what polarity? Of the voltage. Across each resistor. All right. We're done with this one. So after that, I will apply Kirchhoff voltage law in each loop. Apply Kirchhoff voltage law to each loop. Let's apply Kirchhoff voltage law. You have two loops, one to the left, one to the right. All right. Let's just make it simple. We said we assign a direction, a clockwise direction, anti-clockwise direction, whatever the sense, it doesn't matter. But let's say that we agree that this is our sense of direction. Our sense of direction. So I'm going to take the first loop. I call it this, for example, loop 1, and this is loop 2. That's the sense of direction I'm going to move in this direction. If I go for loop 1, let me just take a screenshot of the first one here. So we'll focus only on the one loop. Okay, this is the loop, loop 1. So how you write Kirchhoff voltage law? You will say sigma voltage equals 0. Okay, we know that. But remember how we do that. We start from any side. Well, I start from his side. If you want to start for the, we pick the first sign. That's the first sign of the each polarity. Now I can write the equation. This will be negative, but I don't know the voltage here in 6 kilo ohm. Oh, no, you can, because you know this current is I1, the same I1, I1, I1. So I1 going through 6 kilo ohm. So what is the voltage across 6 kilo ohm? You know the voltage, of course, according to Ohm's law, the voltage is equal Ri. So the voltage across 6 ohm will be equal 6 times I1. That's it. So we have 6 I1. Easy. Now I'm moving in this sense. What this sense? All right. Then I have negative again. 4 kilo ohm. Oh, that's 4 kilo ohm I1, right? 4 times. I can write 4 kilo ohm times I1. Remember now, since we mentioned in the unit, I'm multiplying kilo ohm by I to get voltage. So I1 should be in milliamp to get voltage, right? Because we know 1 volt is equal 1 kilo ohm times 1 milliamp. We know that, right? So without doing that, I know now the currents are in milliamp. Let me continue. So let me just maybe distract your attention now. Negative 6 I1, because 6 multiply I1 give me the voltage here, but this is a negative sign, the first one, minus the voltage here 4 times I1. Then I go minus, and what's the voltage here? That 3 kilo ohm, but you know it's just cut, you know, the 3 kilo ohm here, and the current I, right? So minus 3 I, and then going there you have positive what voltage for? It was 4. Let me, I don't know if it's 4 or something clip. No, it's 45. Oh, that's not a good picture. I'm sorry, guy. I got to do it again because it has to be nothing. When you study, I'm afraid that will make, it's okay. At least we are going to examine it again. I can just have missed clip. Let me just take bigger one. Oh. Okay, that's good. Oh, I don't know what's happening today with my tablet. The old current are erased. Okay, that's good. It's back. I'm sorry for this. Okay. Oh, yeah. So again, let me just explain. I want to find the voltage across 6 kilo ohm. I know the current through this resistance is I1. I don't care about the polarity. I want the voltage. So the voltage is equal to 6 times I1. Why? Because the voltage is equal R times I. So apply be 6 times I1. And we said that before that 1 voltage is equal 1 kilo ohm times 1 milliamp. So now when we apply Kirchhoff voltage law, we'll say sigma voltage is equal 0. I start, this is my sense of movement, and I start, this is the first element. We said we assign the first polarity, so I have, this is the first polarity here. All right, so I'll go, just let me go faster a bit. So we have negative 6 I1. Then when you move, this is the negative, and the voltage V2 will be equal I1 times 4. So it'll be negative 4 I1. And let's just move in the same sense here. I face this one, I have negative, and the 3 kilo ohm times the current, and the current is I, 3I. So be minus 3I. Then I move again, I'll find the positive, and the voltage 45. Positive 45 volts. That's equal to the first equation. So let's just simplify it. That's very important. I'll just take it and right here, negative 6I1, negative 4I1, minus 3I plus 45 equals 0. You have to write this equation as a function of I1 and I2. So I'll say negative 6I1, negative 4I1, minus 3I. You remember I? Let me refresh your memory. I, by Kirchhoff current law, we said I is equal I1 plus I2. So you will have, you replace I by I1 plus I2. Let me just write the note. Kirchhoff current law, we found that I is equal I1 plus I2. Plus 45 is equal 0. Simplify. That's what's happening here is just simple algebra. Minus 4I1 minus 3I1. But be careful, don't make any mistake. If somebody found I did any mistake, please just tell me. So you have negative 6I1, I1. So you got negative 13 I1. I2, you got negative 3 I2. And 45 would go in the other direction, negative 45. So I can multiply by negative sign. So I have negative 13 I1, but positive 3 I2 equal 45. And that will be equation number 2. All right. We did the Kirchhoff voltage law for the first loop. Let's now go for the second loop. I will go again to what we did, and I'm going to take screenshot for the other loop, and I will be careful this time. Okay, great. So how to write? First thing you're supposed to do, I will start from anywhere. So I'll start here and take it the first sign. Easy. Now this is V4. It's 15 and the current I2. So 15 I2. That's 3 kilo ohm and I 3I. We did before, but it's okay. Apply Kirchhoff voltage law in this loop. So you have minus 45, and then you move, you get positive, and the voltage is equal 3I. You move with the sense, you face V4, which is equal positive 15 I2 equals 0. Now I can write negative 45 plus 3, and you know I is equal I1 plus I2. Again, that's from Kirchhoff current law. We just prove it in the first one. I just like to write again, so when you review, you know why we got this one. 15 I2 equals 0. So simplify. Negative 45 plus 3I1 plus 3I2 plus 15 I2 equals 0. Now negative 45 go in other direction, it'll be 40 on the other side, be 45. I1, you have 3, that's it, you have 3 I1, and I2, you have 3, you have 15, that's 18 I2. I hope I didn't do a mistake. Of course, you can divide by 3 if you like to simplify, but you know, I'm not going to waste my time because I'm going to use my calculator actually to solve it. Now we have two equations for I1 and I2. Let me write it here. 3I1 plus 18 I2 equal 45. That's one. The third equation. Second equation, I have 13 I1 plus 3 I2 equal 45. Let me just check. Yes. So I have two equations. I'm going to use my calculator, my simple calculator. I have equation function. I make the mood equation. That's I have in calcium number 5. I use number 1, solving the. Then I enter the first coefficient 13. Enter 3. Enter 45. Enter Then the second equation, 3 enter, 18 enter, 45 enter, and then enter to get the first. Oh, I got the first answer here. So let's just make it in different color. So I have I1, when I solve it, I1 is equal 3. What's in it? Milliamp. Why? All the resistance in kilo ohm. I2 enter 2 milliamp. I got the answer for I1 and I2. I solved I1 and I2. Now tell me, so what is the value of getting I1 and I2? Oh, no. Once you solve this two equation, you got it. Why? Let's go back to the equation. You want to find V2 and V4. What's V2? V2, we said that's equal 4 times I1. 4 times I1. So let me just do, I will write it here. V2, we found it is equal 4 I1. And V4, that's V4. Equal 15 times I2. Equal 15 times I2. That's what I have. All right. All right. 4 I1, 15 I2. So now I'm solving V2 is equal to 4 I1. That's from the that's given, and V4 from the circuit was equal 15 I2. Now I have everything, so I can say V2 is equal to 4 times I1, and I1 is equal to 3 milliamp. All right. Remember, let me write the unit so you will understand why I'm getting volt. So you have 4 kilo ohm times I1, which is equal to 3 milliamp. And I told you before that kilo ohm times milliamp give you 1 volt. So multiply, you get 12 voltage, V2. And V4 is equal 15 kilo ohm times 2 milliamp. That's equal to 30 volt. So I got V2 and V4. It's solved. So this is a good example because it has like two loops, and you assign the current, assign the polarities of each voltage across each resistor. Then you apply Kirchhoff voltage law in each loop, and you found the currents I1 and I2. And you can find anything. If you ask about, for example, if they ask about what is the total current produced by the source, I is equal I1 plus I2. You can say that, all right? If it's required, just I is equal I1 plus I2. That will be equal 3 plus 2 is equal 5 milliamp. You got the total. Okay, what is the power produced by the source? 45 volts. Okay, you go back here, you will see that you have 45 voltage and the current produced I. So it's generating power. So how you calculate generator power? So you say that the generator power by the source is equal to the 45 voltage times 5 milliamp, the total current produced, and then you multiply 45 by 5. But you got to remember the unit. So you say 45 times 5 milliamp, it will give you 225 milliwatt. I know they didn't ask about that, but this is the way that. Okay. So that's the way that we solve Kirchhoff. We solve the circuit using Kirchhoff current law and Kirchhoff voltage law. It's really a good example because the sign of polarity will not given. You don't know anything about the circuit. You solve a complicated circuit. You did it. You go circuit. Okay. When I assign today classwork, I'm not going to assign you the circuit till you finish your lab, but I will assign you another class work which is simple, how to implement or apply Kirchhoff voltage law and Kirchhoff current law, like the first two examples we solved in the lecture. But I'd like to continue, and I want to solve the same problem we just did, the same problem, using series parallel combination. I just want you today, it's an important lecture because it's the first time we're going to solve a real problem using all the laws you got, you learned before. You are applying Ohm's law, parallel, series, Kirchhoff laws. it's really a good example and very important. Maybe it's the most important one we did today in this semester. All right. So another way, let's say that in this example, we need to find the total resistance seen by the source. Let's just find the total resistance seen by the source. It means the source how sees the whole circuit. All right. So when you look at the circuit, you said, okay, you want to see the source. How can the source see the whole circuit here? So you remove this one and you see how it looked like. So I got to rearrange the circuit in a different way. What do you mean? This wire B, C, D, this wire B, C, D. I'm going to bend this wire, put it on the other direction here because they are all connected. So I will do that. Just to make it small so you can see what I'm doing. What I'm doing, I'm going just to sketch this branch that has 45 voltage, and then you have another resistance, 3 kilo ohm, and going with this one 15 kilo ohm. But the other one, I'm going to get it. I just want to observe 4 kilo ohm and 6 kilo ohm, they are connected in series. So I can make it just one wire. That's 4 kilo ohm, and that's 6 kilo ohm. And if you call this is CB, this is A, and this is B, right? And what is C? C is after 4 kilo ohm, that's C. And what is D? D is the ground, the reference is D. All right. Now, just this is B. There is nothing between this wire, there's nothing inside, just to connect it from B, that's B. You can make it from here or here, right? It doesn't matter because it's just the same wire. B, because this is B also, right? There's nothing between. Connected to 15 kilo ohm. And this one ground. Oh. So you see what I did? I redraw the circuit because I wanna ask myself. The question is find the total resistance seen by the source. So in this way, if just for a moment, just let's remove this source. So this is the source. How the source see the rest of the circuit? All right. We'll say that if you have a current going in this, how do you know it's the connection? See, if I have a current I, and this I will split into two currents, I1 and I2. So I know that the voltage across 4 and 6 kilo ohm from this point BD is the same voltage across 15 kilo ohm. So the voltage across 15 kilo ohm is the same voltage across 4 and 6. All right. First of all, 4 and 6 kilo ohm, they are in series. So I can simplify it to 4 and 6 in series. I can make it 10. Right? I can make it 10. That's 10 kilo ohm. And the other one, 15 kilo ohm. And both, they are connected here at point B. And from point B to the source, we have 3 kilo ohm. All right. What about if we make it like that? And the source, that's the source. There's an arrow here. So if the current going in this direction, and I1 go there, I2 go there, so you can say that 10 kilo ohm is parallel with 15, right? It's in parallel. So I'll say it's in parallel. 10 kilo ohm is in parallel with 15. So you can do it in this way and find the equivalent for the parallel circuit. You did that already in the lab, and we did it in the class, so should be familiar with this, equals 6 kilo. So I'm going to replace the parallel resistance by 6 kilo. So I will have one resistor, six kilo, and then I connect it back here to 3 kilo. That's the equivalent resistance or total resistance seen by the source. So you can say now that the total resistance seen by the source is equal 3 kilo ohm plus 6 kilo, 9 kilo. So you can represent the whole circuit by only one simple circuit. One voltage source equal to 45 voltage and one resistance equal to 6 kilo. And in this case, you can find the total current I. The total current I is equal 45 voltage divided by 6 kilo ohm, which will be equal to 45 divided by 6. It's equal 7.5 amp. I'm sorry, milliamp. Because we're using Q. That's milliamp. So that's the current, all right? The total current. So you go back, you say this was the total current I. Then I go back and I take this circuit that I found the equivalent, all right? Because now I know the total current. And I say the total current I now equals 7.5. Equal, this I is equal 7.5 milliamp.
Professor?
Yes, go ahead.
Zoe brought up a good point.
This is what?
The total resistance is 9, not 6.
Oh, yes, that's right. Great. Thank you. Thank you for saying that. All right, let me just correct now. So that will be different completely. All right. You are right. That will equal 5 milliamp. Thank you for proceeding. So you have 5 milliamp. Now we have 5 milliamp entering this node. And these two branches are connected in parallel. This is I1 and this is I2. Do you remember current divider formula? I will remind you, if you have two resistors in parallel, I will just write for you the formula. If you have something like that, and you know the total current I, and you know this is I1, and this is R1, and this is I2, and this is R2. How do you find I1? You will say I1 is equal to the total current I times the opposite resistance, which is R2. See, this is 1, B2, the facing one, divided by the sum. And I2 will be equal to total current times R1, opposite resistance, divided by the sum. This is current divider formula for the two resistance. In this case, I1, this is I1, will be equal to total current, which is equal 5 milliamp, times the opposite resistance. You want to find I1 flowing in 10 kilo ohm, you look for the other one, 15 kilo ohm, divided by 15 plus 10. It will give you the current I1. So in this case will be 5 milliamp times 15 over 25. By 5 is 1, by 5 is 5, by 5 is 1, by 5 is 3. So you get 3 milliamp. Exactly as we did with Kirchhoff's law. You got 3 milliamp. How to find I2? Of course, I say I2 is equal to the total current minus I1. I can do that. That's easier. 5 milliamp minus 3 milliamp is equal to 2 milliamp. I can do that. Or you can use current divider also. It'll be the same. You get the same result. So I got the guys. I got the same current I1 and I2. The same answer I just did in the example using Kirchhoff's law and Kirchhoff current law.